The quest for alien life has motivated countless science fiction tales and has even inspired initiatives by NASA. One of the most fascinating locations in this pursuit is Europa, a moon of Jupiter, which many speculate could contain vital information. Bill Nye, the renowned science guy, is among those who advocate for additional exploration of Europa, convinced that this celestial entity might be essential for uncovering the secrets of life beyond our planet. NASA's Voyager 1 spacecraft, launched in 1977, made a groundbreaking revelation outside our solar system. This finding has attracted the attention of some of the brightest minds today, including Bill Nye. What Voyager 1 discovered were ionized gas particles actively colliding and interacting just beyond the heliosphere, the bubble-like region formed by the sun's solar wind. These observations provided significant insights into what conditions may exist beyond our solar system. Could these be signs of extraterrestrial life? This inquiry has captivated the imaginations of scientists and space enthusiasts alike. Bill Nye has long been a prominent figure in the search for alien life. His enthusiasm for the unknown is clear in his interviews and presentations, where he often stresses the significance of space exploration. The discovery made by Voyager 1 has further fueled this passion, providing new data that could potentially answer the age-old question: are we solitary in the universe? To comprehend why this discovery is so crucial, it's important to revisit the early days of space exploration and the events leading to the launch of Voyager 1. In the early 1970s, NASA had recently accomplished a monumental achievement by sending humans to the moon. This triumph ignited widespread excitement within the scientific community, and plans were soon underway to explore even farther into space. NASA's next objective was to investigate the outer planets of the solar system, but sending humans on such a mission was not yet practical. The vast distances and the limitations of 1970s technology necessitated reliance on robotic spacecraft for these ambitious explorations. At that time, the Cold War was in full effect, and the United States was engaged in a fierce rivalry with the Soviet Union. This competition extended into space, where both nations were striving to demonstrate their technological superiority. The Soviets had made the first significant advances in space exploration, launching the first artificial satellite in 1957 and sending the first man, Yuri Gagarin, into space in 1961. However, the United States caught up with the Apollo 11 mission in 1969, landing astronauts Neil Armstrong and Buzz Aldrin on the moon. This victory marked a turning point in the space race, but the U.S. knew it couldn't rest on its accomplishments. The rivalry with the Soviet Union continued to drive NASA's ambitions to maintain their lead in space exploration. NASA needed to move beyond the moon, and the new goal was to explore the outer planets. The agency began designing spacecraft that could journey deep into space. One of NASA's initial attempts was the Pioneer 10 spacecraft, launched in 1972, which became the first to fly by Jupiter and send back images. Pioneer 11 followed the next year, also heading toward the outer planets. However, NASA desired a more advanced spacecraft that could capture detailed images and data from not only Jupiter but also Saturn, Uranus, and Neptune. This led to the creation of the Voyager program. The plan was ambitious: to utilize a rare planetary alignment known as the Grand Tour to slingshot the spacecraft from one planet to another using gravitational forces. This alignment, occurring only once every 156 years, would allow NASA to study all the outer planets in a single mission, saving both time and resources. To achieve this, NASA constructed two Voyager spacecraft. Voyager 1 was designed to take a shorter route, visiting Jupiter and Saturn, while Voyager 2 would take a longer path to reach Uranus and Neptune. On August 20, 1977, Voyager 2 was launched, followed by Voyager 1 on September 5 of the same year. These twin spacecraft would go on to make some of the most astonishing discoveries in the history of space exploration. Voyager 1 began capturing images of Jupiter on January 30, 1979. These photographs revealed details of the gas giant that had never been seen before, including its Great Red Spot, a massive storm that has been raging for centuries. But Voyager 1's mission didn't conclude there. After completing its flyby of Jupiter, the spacecraft continued on to Saturn, where it transmitted more groundbreaking data. The discoveries made by Voyager 1, particularly its detection of ionized gas particles outside the solar system, have had a profound impact on our understanding of the universe. As the Voyager missions continue to relay data from the far reaches of space, the quest for alien life remains as urgent as ever. Bill Nye and other scientists believe that exploring places like Europa, with its subsurface ocean, could provide the next major breakthrough. What we learn from these missions could alter our understanding of life in the universe forever. Every 96 seconds, Voyager 1 captured images and compiled them to create a colored stop-motion video. Using this method, Voyager 1 was able to send back a film showing 10 rotations of the largest gas giant. By February 10th, Voyager 1 had entered the planet's moon system, transmitting footage of natural satellites revolving around the gas giant. By the following month, it discovered a thin ring of dust and ice surrounding the planet that was invisible from a great distance. This proved that Saturn was not the only planet encircled by rings. The ring measured just less than 30 meters in diameter, and it puzzled scientists how much they were unaware of this planet. By March 5th of that year, Voyager 1 had its closest encounter with a large planet, separated by a mere distance of 174,000 miles. During this special event, the spacecraft encountered several of Jupiter's moons, including Io, Europa, Ganymede, and Callisto. The pictures it transmitted provided great insight into the strange world of natural satellites, as some of them had almost nothing in common with our moon. These satellites were known as the Galilean moons, named after the astronomer Galileo Galilei, who discovered them back in the 17th century through his telescope. One of the smaller moons observed by Voyager 1 was Amalthea, a reddish and oddly shaped satellite featuring a distinctive surface makeup. Images transmitted by the spacecraft revealed that it consists of ice and silicate substances. The reddish hue on its surface arises from organic materials, and its strangely twisted surface indicates minimal internal activity compared to other moons. Io was identified as the most geologically active body in the solar system, showcasing hundreds of active volcanoes and lava flows visible from its exterior. These volcanic eruptions were fueled by tidal heating from Jupiter's immense gravity, giving the satellite the appearance of a volcanic inferno rather than a mere moon. Europa stood out for its smooth, icy surface, concealing a vast ocean of water beneath. Many scientists speculate that life could thrive under the ice, making this moon a prime candidate for extraterrestrial organisms. A few craters on its icy surface suggested past impacts from asteroids and smaller comets. Next, images captured arguably the largest moon in the solar system, Ganymede. This satellite was so massive that it exceeded the size of the planet Mercury. It is substantial enough to possess its own magnetic field, and the images indicated that its surface is primarily covered in rock and ice. Ganymede's potentially intricate geological past continues to perplex scientists today, and it likely contains a molten core deep within, which generates its strong magnetic field. Another significant moon observed by the spacecraft was Callisto, the second largest of Jupiter's moons. Its heavily cratered exterior indicated a history of frequent collisions with asteroids, coupled with a lack of geological activity. Like Europa, it also harbors an ocean beneath its surface, making it another candidate for potential extraterrestrial life. The spacecraft discovered 2 additional moons, named Thebe and Matisse. The images suggested that both are small and irregularly shaped, situated much closer to the planet than the other satellites. It's noteworthy that the planet and the moons observed were named after popular mythological figures. The large planet was named after the famous Greco-Roman god of thunder, while the revolving satellites were named after the women who shared intimate relationships with him. After the spacecraft's time at Jupiter, a trajectory adjustment was made to prevent it from orbiting the planet indefinitely, preparing it for a journey towards Saturn. Approximately 6 months later, in October, another course correction was executed to avert a potential collision with Titan, one of Saturn's moons. The encounter with Saturn proved just as stunning as the previous one with Jupiter, with the spacecraft discovering 5 new moons, a ring system consisting of thousands of bands, transient clouds of particles known as spokes, and a new ring that couldn't be detected from a great distance. It was also found that certain satellites are responsible for maintaining the distinct structure of Saturn's rings, which appear beautifully organized thanks to these satellites. In the weeks that followed, Voyager 1 captured remarkable images of Saturn's moons, including Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. The photographs suggested that these moons were primarily composed of ice, with potential oceans beneath, increasing the possibility of extraterrestrial life thriving beyond Earth. However, the most astonishing discovery was Mimas, a relatively small moon featuring a large impact crater so expansive that it was named Herschel. This feature made Mimas reminiscent of the Death Star from the beloved science fiction series Star Wars. The crater's presence indicated low geological activity and a significant past impact with a large asteroid. The other moons observed by the spacecraft mostly consisted of ice, with only a few distinguishing characteristics among them. However, the most captivating of the moons captured by Voyager 1 was Titan, closely imaged on November 12 at a distance of less than 3,000 miles. The images revealed a thick atmosphere that completely concealed the surface. This atmosphere was primarily composed of nitrogen, with average pressure equivalent to sea-level air pressure on Earth, albeit at -300 degrees Fahrenheit. Features of the satellite suggest it may be the first body in the solar system, aside from Earth, where liquid could exist on the surface. The chemical conditions necessary for life appeared to be present on Titan, with strong evidence pointing toward the existence of essential hydrocarbons vital for life formation. The spacecraft's closest approach to Saturn occurred on November 12, at under 8,000 miles from the planet. By 1989, all planned encounters with the four gas giants had concluded for both spacecraft. However, they remained operational and were incorporated into the Voyager interstellar mission, which officially began on January 1, 1990. The new objective was to travel beyond the outer planets of the solar system and, if feasible, even further. The more specific aim was to collect data on the region of space dominated by Earth's magnetic and solar fields, as well as the interstellar medium. On February 17, 1998, Voyager 1 became the most distant human-made object, surpassing Pioneer 10 at a distance of nearly 70 astronomical units. By September 2017, 45 years after its launch, the spacecraft continued to function effectively, transmitting data from its instruments to NASA's Deep Space network. Scientists were amazed that the cosmic ray telescope and magnetometer were still operational after over 40 years of traversing space. Now traveling through interstellar space, scientists hoped that something out there would receive the message we sent forth. Voyager 1 and Voyager 2 ventured further from the Sun, and their missions gained new significance. Voyager 1 entered interstellar space in August 2012, marking humanity's first foray into this uncharted territory. This milestone provided scientists with a unique opportunity to study the conditions of space beyond the heliosphere, the protective bubble enveloping our solar system. Voyager 1's data has been crucial for understanding the nature of cosmic rays, magnetic fields, and plasma interactions in interstellar space. Meanwhile, Voyager 2 continued its mission to explore the outer edges of the solar system, entering interstellar space in November 2018. Its trajectory offered valuable comparative data alongside Voyager 1, enhancing our understanding of the boundaries of the solar system. Both spacecraft carry a golden record containing sounds and images meant to depict the diversity of life and culture on Earth. This record serves as a message to any potential extraterrestrial civilizations, illustrating humanity's desire to connect with the cosmos. As the Voyagers persist in their journey, they also contribute to the broader field of astrophysics by observing phenomena such as the interstellar medium, the local interstellar cloud, and the interaction of solar wind with the galactic environment. Their findings have provided insights into the structure of the heliosphere and the nature of the interstellar magnetic field. Data from both spacecraft is vital for future interstellar missions. As technology evolves, scientists and engineers are assessing the performance of the Voyagers to develop new spacecraft capable of traveling even further into space. This includes potential missions to explore nearby star systems or investigate the outer boundaries of the Milky Way galaxy. The legacy of the Voyager missions lies not only in their immediate discoveries but also in their role as pioneers for humanity's deeper exploration of the universe.